Today's lesson is a continuation of section 9.1, add and subtract polynomials. Now in the first part of this section, I actually just talked about some terminology like what is a polynomial, and we talked about monomials, binomials, trinomials, the different types of polynomials we'll see in this chapter and so on beyond that as well. Now we'll actually get into what this section, the title of it says, adding and subtracting polynomials. The nice thing about this is that adding and subtracting polynomials, students are going to find pretty quickly, is a lot like something we did back in chapter 2. It's actually a lot like when we collect like terms. We try to add some expressions together or add some terms together, collecting the like terms. What does that mean? Remember, that's just like collecting the terms that have the same variable part to them. So I'm just going to make up a problem here just as a reminder. What does this entail? Remember, you probably had problems in the past, something like this, like 3x plus 4y minus 5x plus 7y plus 10. So just something like this, where I'm adding a bunch of terms together. Again, now we know these could also be called monomials in this chapter, but I'm adding all these terms together. I can't combine them all, but I can combine ones that have the same variable part to them. So if I have something, if I'm looking at these terms and add them all together, well, I could say that the 3x and this 5x are both have the same variable part, so I can combine them. Now, one thing to be careful of is in my expression is make sure that I notice the sign in front of this 5x is actually a subtraction sign. So that means that how I combine them is I'm actually going to take 3x minus 5x. So that is important to note. The sign in front of a term tells you how you're going to combine it with other ones. So 3x minus 5x. What would that give me in this case? If I combine those, I'd get negative 2x. So there's me combining those two like terms. I have some more like terms as well. I have 4y and 7y, and again, in this case, it's got a plus sign in front of it. So this is just like 4y plus 7y then. All I do is I add the two coefficients of those terms, keep that same variable part, which is y. So this ends up just being plus 11y. And then at the end here, again, I've combined terms with x, I've combined the terms with y. I still have this plus 10 at the end. That constant, I can't combine those with either of the other ones because they have variables. This does not. This is just a constant, plus 10. So that just comes along with my expression as well. And this is how I would simplify that expression by combining like terms. I would get an answer of negative 2x plus 11y plus 10. So doing things like this, recall how you've done this in the past. This is going to help us a lot in this particular section. So now going back to my first example, the problem says add the polynomials. So I have two different polynomials here, and realize again each one has three terms, right? So like we talked about in the first part of this section, I can call these trinomials. They each have three different monomials in it. Same thing with this one, 1, 2, 3. They each have three different monomials, so these would each be called trinomials. The parentheses sections them off, telling me that that's this trinomial plus this trinomial. So I'm going to add those two together. Well, again, what happens when I add two polynomials, or in this case, two trinomials together? I can't add all the terms. I can't just combine them all and smash them together. But I can add the ones that have the same variable part to them, just like we've done in the past. So if I look at these carefully, well, 2x to the third and 4x to the third, those have the same variable part. The variable even has the same exponent. That is important. I can't combine 2x to the third and 5x squared. They don't have the same variable part. So no, those would not be considered like terms in a problem like this. I can't add those two together. But I can add 2x to the third and 4x to the third. And when I add those, again, I add the coefficients because that's what it's telling me to do. 2 plus 4 would give me 6. So now I have 6x to the third. As a reminder, often when I talk about collecting like terms, sometimes if it helps you, you could think of saying, well, I have 2 apples plus 4 apples. Well, that gives me 6 apples. That's just a reminder to students that, yeah, I just add those coefficients in front of the number, and I keep the same variable part though when I'm combining like terms, and when I'm adding, in this case, polynomials together. Excuse me. I would just get 6x to the third power. Now moving on to the next set here. What else can I combine? There are more I can still combine here. 5x squared, and then I have a minus. Again, the sign in front is important. Minus 2x squared. So 5x squared minus 2x squared give me plus 3x squared. And again, like I actually should have the first time here, what I usually like to do is I just like to cross off the terms that I've combined then. So I've combined all the x to the third powers. I've combined the x squareds. And now I've just got a couple terms left here. Now if I look at these last two, I have 10 over here, and I have plus 8x over here. I can't combine those two. They're not like terms. But I'm just going to keep writing them in decreasing degree order now, like we learned in the first part of this section. So this would have a degree of 1, this would have a degree of 0. So now I'm going to write plus 8x, and then my constant at the end, plus 10. So there's me adding both those polynomials together. Oops. There's me adding those two polynomials together. And that's my result. 6x to the third plus 3x squared plus 8x plus 10. Now in the book, it'll talk about a few different ways that you can add two polynomials together. They talk about a horizontal and a vertical way to add these. And you can see it this way as well. And I'm okay if you use either of these two methods. I kind of use a version of the horizontal method, but showing you the vertical method, it's just the fact that you're going to line up all your like terms, which again makes a lot of sense. And we actually have done something like this very similar in the past too. When we did chapter 7, and we talked about using substitution on a linear system, we've done things like this where we line up the system, line up the terms that are alike. So this isn't that new. So if this makes the most sense to you and this is the easiest way to get the right answers, then this is the way I would do it vertical format. Okay, I'd line up the terms with x to the third like I did there, line up the terms that are x squared, line up the terms that have x. Well, in this case, there isn't one, correct? So nothing goes in that spot. That's just kind of a blank spot then for this particular problem. And same thing, this is just realize this is the problem from above, in case you haven't seen already. But remember, there's no constant in that second one, so I have nothing to add to that 10. So I still line them up, though, like it did, in decreasing degree order from left to right. These have a degree of 3, these have a degree of 2, these have a degree of 1, these have a degree of 0. So yep, I'd line them up like that. And then now I'm just going to add them vertically, as it says. So if I add 2 plus 4, I get 6x to the third. 5x squared plus negative 2x squared would give me 3x squared. Again, there's nothing to combine with that 8x, so that's just plus 8x. And then I just get 10 at the end there, which, again, as you can see, is the same answer I got from the very first time I did the problem too. So that's nothing new. So, but just a different way to get to the answer. If you want to add them vertically, it's a nice visual way to do it as well. The book also talks about a horizontal format, which is kind of like what I did above, and that's the way I will typically do the problems when going through these. Because I don't rewrite them in the vertical format. I use that very nicely for the, again, using substitution or elimination we were doing when we did solving linear systems. But usually I'll just go with the horizontal format here, which is kind of like what I did above. I just kind of align the terms that were alike. They actually write them next to each other. So here's your problem. And it says, well, here are my like terms. So then they rewrite it next to each other also. And then find their result, like in this case, 6x to the third. Plus, and then they add these two together, the terms that have x squared, and they get 3x squared. So very similar to what I did. I kind of cut out one step. I think we are capable of doing that. But if you would like to realign them too, that's definitely nothing wrong with that. I will probably do the horizontal format here in my lesson, and many times when I'm doing the problems. And again, I will just more look to combine like terms and cross them off as I go. I feel like that's the way to make sure that I've combined all the like terms and still written it in decreasing degree order. So that first example, adding two polynomials together, that again, it was like something we've done in the past. It's like a lot like combining like terms, and if that was all there was to this, then we'd pretty much be done with the lesson so far. But one thing to note, though, we can subtract two polynomials, and this is something, though, that we've also done in the past, something that we've dealt with, again, when we were doing elimination and solving a system. So something, as I talk about here, students usually can recall and remember, oh yeah, they kind of remember that we did something like this also. Look at these two polynomials in my next problem here. In this case, they're both trinomials, right? It says 5x to the fourth minus x to the third plus 8x, and then minus, we're subtracting that other polynomial. Well, again, I'm going to liken this to something we did when we were doing elimination with systems. So remember when you had something like 2x plus y equals 10, and then 2x plus 3y equals 20. Well, when we wanted to eliminate a variable in a problem like this, we actually ended up subtracting these equations to eliminate the 2x in this case. And remember though, how did I have students do this? And again, you can look back at those lessons or think back to it, maybe you'll remember here. But when you're subtracting things like this, two equations or even two polynomials as we'll see, I recommend instead of subtracting, I would add, but just change all the signs of all the numbers. I think it makes it a lot easier and causes a lot less mistakes. Because when we try to subtract, if I have to remember, taking away all my signs that I just changed, if I have to always remember that it's 2x minus 2x, and then y minus 3y, and then 10 minus 20, okay? That just seems to be a lot of little steps there, then sometimes people forget that they're subtracting every time. So I'm going to recommend, just like I did back then, in a problem here where I'm subtracting two polynomials, the first thing I'm going to tell you to do is actually change this to an addition problem, and then just change all the signs. And I think, one, it's a little easier for our brain, too, I feel like, to add numbers. And two, then you don't always have to remember that, oh, I'm subtracting this term minus this term. And then, oh, I got to subtract this one as well, and this one. So I find it a lot easier if you just chop dash everything, change the problem to addition, and just change all the signs in. Because, again, it means you're subtracting all these terms. So it's kind of like when we do a chop dash or chop chop. Subtracting each of those is just like changing the sign of each one and adding instead. So I'm going to recommend that's the way you go about this. So if you can handle it the other way, I guess you can give it a try, but I would rather you chop dash everything and then try to add. I find a lot less mistakes when we do it this way. So now it's just like the first problem we did though. If I'm now adding these two polynomials now because I've changed the signs of each of these, so which ones can I combine? Well, 5x to the fourth, and now this is negative 2x to the fourth. When I combine those, I get 3x to the fourth. And again, I just like to cross them off to make sure that I've combined all the ones that I can. Moving on here, I have a negative x to the third plus 11x to the third, so that's going to give me 10x to the third power. And now I'll combine those two. And then last term in this polynomial, I have 8x. Last term in this polynomial, I have 21. So again, I can't combine those, but I can just kind of tack those onto my problem and put plus 8x and plus 21. Going through another one here with you. So number 3. Again, this one's subtracting the two polynomials together. So my recommendation, again, if you want, you could think, okay, well, I got to take negative 7x minus negative 7x and 15 minus negative 16. You can do it that way. But I find that just seems like a lot of mess and a lot of things that we could potentially forget then that I'm subtracting every time and then trying to think in our head, oh, it's a minus, a negative, so I have to add. I just find that to be a lot that we're doing in our head that we don't have to be. I think we can change this problem and get the nice visual instead of saying, oh, I'm adding these, and this is just negative x to the third. This is just positive 7x now, and this is just positive 16. I think that ends up being a lot easier, causes a lot less confusion, too, when you're trying to get your answer. Looking at this one, the first term in this one is negative 8x squared. I don't have any x squareds on this side. In fact, all I have is an x to the third power. So really, since that's a degree of 3, that's actually going to be my first term, is the one that I have over here, this negative x to the third. So that's going to be the first term when I'm rewriting this polynomial and combining things. I'm going to write that first, negative x to the third. And then again, I don't have any x squareds, so this is my next term, 8x squared. Now, I'm on to the next ones here. And look carefully here. This says negative 7x and now plus 7x. Well, negative 7 plus 7 is 0. So these actually just cancel out. And they aren't even going to factor into my end result. Again, if we had that subtraction sign here before like we did, and we were trying to think negative 7 minus negative 7, I still see students who then try to combine those and get negative 14x. But because we chop dashed and we changed all the signs in that second one, it's a lot easier, I think, to think, oh, negative 7 plus 7, well, that's 0. So I think students have a better chance of getting the right answer when you change all the signs in a subtraction problem. And then the last two here, 15 plus 16. Again, even that problem becomes a lot easier. Now it's just 31. So my result is negative x to the third minus 8x squared plus 31 when I add those two polynomials together. I'll go through one more here just as a reminder that, again, we're not always subtracting. You have to determine for each problem, are you subtracting or adding? So in this one, this is addition. So I don't have to change any signs at all. It's just like collecting like terms from this point. And now in this one, I see 5x to the third, and I don't see any other x to the thirds anywhere else in this problem. So that's just the first one I'm going to write down is 5x to the third. And now I'm done with that part. Then if I look to what my next highest power is, I can see 4x squared, and I don't see any other x squareds. So I'm just going to write that one in my problem as well. Now if I look carefully, this particular polynomial happens to have 4x minus 2x. So I can combine those, and I can combine it with this plus 3x on the other side as well. So I can combine all those, again, like terms. 4x minus 2x would be 2x. Plus 3 more x would just be 5x. So I can combine all those and get 5x. And then my last part, minus 6 at the end. So there's my polynomial when I add those together. Again, one like that when I'm adding, it's just like combining like terms. If you're subtracting, I recommend just changing all the signs of the second polynomial to one you're subtracting, and then go ahead and adding with the different terms, or the different signs in front. I think that makes these a lot easier.